Okay, I would like to now talk about evaluating. Now that we've discussed the definition and the symbolism a little bit, let's talk about what it means to evaluate. Evaluate roughly means to determine the number. Expressions are evaluated, equations are solved. We evaluate expressions, we solve equations. So you might want to keep that in mind as you proceed. An expression doesn't have the equal sign. An equation does. That's the difference, or the clear difference anyway. So let me give some examples of evaluating a root expression. I've already done some of that. Let's just keep going. What if we had the square root of 81? Then the question we're asking ourselves is what squared, what times itself gives us 81? The answer is 9. Now, how did I know that? Mostly, I just remember my times tables for small numbers. And if it's the root of some gigantic number, I'll be honest, I put it in the calculator. There is a method for approximating roots without using the calculator. Several historical methods, but I'm not going to go into that in this video series. Let me at least check this to verify if I'm right. I could say, okay, what is 9 squared, since that was the question. 9 squared is indeed 9 times 9, which is equal to 81. So that's okay, it checks out. But suppose we had, let's ask a different question. How about the 4th root of 81? So now we're asking ourselves, what to the 4th power is 81? What times itself 4 times? Now, it turns out that the answer to this is 3. How come? Let me again just perform a little check. 3 to the 4th power is 3 times 3 times 3 times 3, which is, notice that this is a 9, this is another 9, so you could say that's the same as 9 times 9. Yep, 81. It checks out. Now, how do you get the 4th root of a number? You can make a table, I guess, for yourself and refer to the table. And the table would consist of a table of powers. So you start with numbers 1 through 10, and then in the next column show all those numbers squared, all those numbers cubed, all those numbers to the 4th power, so on and so forth. Or there is a way to do that in your calculator, but I'm not going to show that at this point. Notice something interesting, however, about 81. I'm showing over here that it's 3 times 3 times 3 times 3. That's called the prime factorization of this number in this case. And one way to do that, to find those numbers, is to use a factor tree. And it's going to be helpful in finding the root, or can be helpful in finding the root. It can be also helpful in simplifying roots. So let me show quickly the prime factorization. 81 is 9 times 9. Those aren't prime factors, they're not prime numbers. So I'm going to break down the 9 into 3 times 3, and this other 9 into 3 times 3. And so 81 is the product of these prime factors, which means I could show that root, the 4th root of 81, as the 4th root of 3 times 3 times 3 times 3. And remember the question. The question was, what to the 4th power gives me this number inside? And we can see that it's 3 to the 4th power, so the solution must be 3. You might see it written like this. Okay, same thing. What to the 4th power gives me this number on the inside? Well, the number on the inside is 3 to the 4th power, so the answer is 3. Again, to see it like this. Whenever this index here and the power of the number on the inside match up, then the root is just the number taken to that power there. That's kind of a nice thing to notice. There are lots of other things to notice, but let me just start with that to point out the prime factorization and how you can use that to evaluate a root. For example, just to give another one, suppose we had the cube root of 125. Now, if you looked at the prime factorization of 125, then you don't have to do a little tree. You can do it horizontally too, and I'll do that here. I can say that it's at least 5 times something, right? I know that because there's a 5 on the end, and it turns out it's 5 times 25. And then you can say, oh, 25 is 5 times something. So retain that first 5 you had, times, this is 5 times 5. And now we've achieved the prime factorization, prime numbers only, as a product that give us that number in there. And notice what that is. That is 5 cubed. So the answer to this, what cubed is 125? 5 is the number. And so there's kind of a non-calculator way of evaluating some of these roots, in addition to simply memorizing several powers. I don't have a lot of powers memorized, so I would probably punch this up in a calculator. If not, I kind of like doing this prime factorization and visualizing it that way, especially when variables are involved. But let me move on, and in the next video, I'm just going to show more examples of evaluating, also showing cases where it doesn't come out to a real number. So let's take a look at that in the next video.